Hello students, in this lesson we are going to talk about addition and subtraction of fractions. Now, before we dive into it, what is then a fraction? A fraction is actually an incomplete number, right? And fraction is basically divided into two parts. So it is always in the form of x over y, where x is known as a numerator and y is known as the denominator. So the one at the top is known as the numerator, while the one at the bottom is known as the denominator. Then this line here is called the fraction line, right? So numerator, denominator, and the fractional line. The fractional line is the line that divides the numerator from the denominator. And one thing we need to understand again is that this fraction is into types, and the first type is proper fraction, and the second type is improper fraction. Okay, imagine carrying a bag of cement on your head. Is that not heavy? Of course, it's very, very heavy. And also carrying a book on your head. Which one will be easier? Of course, carrying a notebook on your head will be easier than carrying a bag of cement. So when you carry a bag of cement, we can say that that is not proper. That's improper, right? And whenever you carry a notebook on your head, we say, it's okay. That's proper. So improper fraction is a type of fraction that the denominator is smaller than the numerator. So whenever you have, like example, 2 over 3, this is a proper fraction. Why? Because the denominator here can carry the numerator, so the number at the bottom can carry the number at the top. We now say it's proper, right? Then when the denominator is smaller compared to the numerator, that is when the number at the bottom is smaller compared to the number at the top, we call it improper fraction. For example, when you have 5 over 2, of course 2 is too small to carry 5. That's why I made an example with carrying cement. So this is improper fraction, right? So that is a brief introduction about fraction. Now let's go into the topic for the day: addition and subtraction of fraction. And addition and subtraction of fraction go hand in hand because they share a lot of things in common. As we start, you understand it better. So let's see. So that's the first instance, when the denominators are the same. And the second instance is when we have different denominators. So these are the two instances we have when considering addition and subtraction of fractions. So whenever you have a fraction adding another fraction and the denominators are the same, of course the way you approach it will be different from fractions that have different denominators, right? So let's see the two instances. I'm going to start with the first one. Alright, as we've seen in the introduction that there are always two instances when dealing with addition and subtraction of fractions. And the first instance is when the denominators are the same denominators. So what happens when you are adding fractions and the denominators are the same? The simple thing to note here is that when adding or subtracting fractions that have the same denominators, you simply add or subtract the numerators. Simple, is that not? So for example, when you have 1 over 7 plus 3 divided 7, you can see that the denominators are the same. Is that not? Since the denominators are the same, we'll simply add the numerator. So it will be just be 1 plus 3 over, then carry 1 of the denominator, which will be 4 over 7. Simple. So whenever you're adding fractions that have the same denominator, just add the numerators. Another example is when you have 4 over 8 plus 7 over 8. what will be the answer? You simply add the numerator since the denominators are the same. So we're going to say this one is something as 4 plus 7 over 8. Is that not? So 4 plus 7 is actually 11. Now, you can't leave our answer like this. Whenever after the solution, you have an improper fraction because the denominator, can you see, the denominator is smaller compared to the numerator. You can say that 8 cannot carry 11. Then you will have to convert it to mixed fraction. And in changing it to mixed fraction, we're going to say 11 divided 8. If you don't know how to do it, you can just say, okay, let me count 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Divide 8. So we're going to group in 8, 8. So we have 1, 2, 3, 4, 5, 6, 7, 8. Right? It goes one time remainder 3. So it will go, you can say it will go one time remainder, then 3 over the 8. Can you see? So this is the answer. Right? Let's see more examples. All right, another example is when you have 2 divide 3 plus 2 divide 3. I say 2 divide 3 plus 2 divide 3. Since the denominators are the same, what I'm going to do, we simply add the numerator, which is 2 plus 2 over, just pick one of the denominator, which is 3. So it will be 4 over 3. And this is an improper fraction because 3 cannot carry 4, right? So what I'm going to do, say 4 divide 3. 1, 2, 3, 4. Divide by 3. It will go one time, remainder 1. So you have one time, remainder 1. Then over this denominator, 3. So this is the answer, right? All right, let's see an example with subtraction. So we have 10 divide 2 minus 3 divide 2. Can you see? In this case, we have subtraction. It's the same thing. Since they have the same denominator, we're going to subtract the numerator. So it's going to be 10 minus 3 divide 2. And 10 minus 3 is actually what? 7 divide 2. And this is an improper fraction. What I'm going to do, we're going to say 7 divide 2. So we count it 1, 2, 3, 4, 5, 6, 7. Divide by 2. This 1, 2, 3. It will go 3 times remainder 1. So say 3 times remainder 1 over this denominator 2. So this is the answer. 3 whole number 1 over 2. Alright, another example under subtraction. When we have 6 over 11 minus 4 divide 11. That's going to be 6 minus 4 over 11. 6 minus 4 is 2 divided by 11. This is a proper fraction, so the answer remains the same. Alright, but sometimes you may have a question in mixed fraction, even though the denominators are the same. For example, we may have 2 whole number 1 over 2 plus 3 whole number 1 over 2. What are we going to do? There are 2 ways of solving this, even though the denominators are the same. The first way of solving it is by converting this to an improper fraction first. And how we're going to convert it? You're going to say this whole number times the denominator, which is what? 2 times 2 is 4. Then plus 1. 4 plus 1 is 5. So it's going to be 5 over 2. Then plus 3 times 2 is 6. So 3 times 2 is plus 1 is 7. So we're going to have 7 divide 2. Can you see? Now the denominators are the same. We're going to simply add the numerator. So we're going to 5 plus 7 over 2. And 5 plus 7 is 12 over 2. 12 divided by 2. 2 here is 1. 12 divided by 2 is 6. So the answer is 6. Can you see? That's when you have a mixed fraction. Another way of solving this is simply by just add the whole numbers, that is 2 here and 3 here. If you add them, you're going to have 2 plus 3. Then put the fractions in bracket. We have 1 over 2 and we have plus 1 over 2. Can you see? So 2 plus 3 is 6, right? Then we have open bracket 1 plus 1. Since the denominators are the same, you add the plus. We have 1 plus 1 is 2 over 2 over 2. So we have 2 divided by 2 is 1. So in this case, the answer is going to be 6 times this one is 1, this one is 1. 2 divided by 2 is 1 times 1, which is equal to 6. So there are two ways of solving it. Either to add the whole numbers together, then multiply it by the fractions added together. All right, let's see one more example that has to do with mixed fraction. So we have 5 1 over 7 plus 3 1 over 7. So using the first method, we're going to convert it to improper fraction. It's going to be 5 times 7, which is 35. And 35 plus 1 is going to be 36. So we're going to have 36 divide 7 plus 3 times 7 is 21. And 21 plus 1 is 22. So we're going to have 22 divide 7. So since the denominators are the same, we're going to simply add the numerators, right? So 36 plus 22 over 7 is what? 58, right? So 58 divide 7. And 58 divide 7 is going to go 8 times remainder 2 over 7. Can you see? Very simple. So using the second method now, we're going to add the whole numbers. These ones, add them together, will be 5 plus 3 into, then these ones, 1 over 7 plus 1 over 7 again plus 1 over 7, right? So 2 plus 3 is 8. And we have into, since the denominators are the same, right, we're going to simply add the numerator, which is 1 plus 1, and it is 2 over 7. So our answer is going to be 8 whole number 2 over 7. And you see it's the same with this. All right, as we've said that there are two instances in addition and subtraction of fractions, and we said that the first instance is when the denominators are the same, and the second instance is when the denominators are different. Now we've already seen when the denominators are the same, and now let's see what if the denominators are different. What are we going to do? So the secret is that when the denominators are different, we are going to find the LCM of the denominators. And if you have problem with finding LCM, you can check out my previous videos on LCM, that is lowest common multiple. So let's give it a try. For example, when you have 1 over 4 plus 2 over 12, can you see the denominators are different? So what are we going to do? We're going to simply find the LCM of the denominator. So draw a line. We say LCM here. That's the lowest or least common multiple. And how can we find the LCM? We're going to say what? 4 and 12. Draw a line, right? So 2 can go here. 4 divided 2 is 2. 12 divided 2 is 6. Remember, we're using prime numbers. So 2 can still go. 2 divided 2 is 1, and 6 divided 2 is 3. Am I right? So is there a number that 2 can divide? No. Check the next prime number, which is 3. 3, of course, can divide. So 3 divided 1, write the 1 down. 3 divided by 3 is 1. So what is our LCM? Our LCM here is 2 by 2 by 3, which is what? 2 by 2 is 4, and 4 by 3 is 12. So that's our LCM. So we'll come back here and write 12. All right. So we said this 12 divided by this 4. That's the first thing we'll do. 12 divided 4 is going to give us 3. Don't write the 3, right? Let's write the 3. Keep the 3 here. 12 divided 4 is 3. Am I right? So then we said this 3 times the numerator 1. 3 times 1 is actually 3. So we're going to write 3 there. So 3 plus 12 divide 12. This 12 here. 12 divide 12 is 1. 1. Then 1 times 2 is 2. So write 2. Can you see? So now 3 plus 2 is 5. So it will be 5 over this LCM 12. And that is the answer. 5 divide 12 is the answer. 5 over 12. Let's see more examples then. Alright, another example with different denominators. 2 divide 6 plus 1 divide 2. So as we said, we take the LCM, and the LCM will be 6 and 2. So let's find the LCM of 6 and 2. 2 will go here 3 times, and 2 divided 2 is 1. What can go? 2 cannot go again. It's 3. 3 here is 1 and 1. So the LCM is 2 times 3, which is 6. So come back here and write 6. So 6 divided 6 is equals to 1. So we have 1, right? And 1 times this 1 times 2 is 2. 2 plus 6 divided by 2 is actually 3. So we have 3. And 3 times 1 is 3. So we're going to write 3. So 2 plus 3 is going to give us 5, right? So we have 5 over 6. And that is our answer. Alright, what if the subtraction of fraction that have different denominators? We're going to use the same method. For example, when we have 9 divide 10 minus 1 divide 2, we're going to take the LCM as well. So LCM of 10 and 2. So 2 can go. 10 divided 2 is 5, and 2 divided 2 is 1. So what can go? 2 cannot go. 3 cannot go. Remember, we only use prime factors. 5 can go. 5 divided 5 is 1 and 1. So the LCM is 2 times 5, which is 10. So come back here and write 10. 10 divided 10 is 1, right? So 1. And 1 times 9 is 9. Minus 10 divided 2 is 5. So, and 5 times 1 is 5. So we're going to write 5 there. So 9 minus 5 is actually 4. So we're going to be 4 divide 10. So 4 divide 10. 2 can divide both of them. So we can say 2 here to the lowest term. 4 divided by 2 is 2. And 10 divided 2 is 5. So our answer will be 2 over 5. This is the answer. Alright, another example that have to do with subtraction is when we have 2 divide 3 minus 5 divide 10. We take the LCM of 3 and 10, right? So 2 here is 5, and 3 divided by 2 is not possible. So it's not going to divide it down the remainder. So we have to write the 3 down. So what can go? The next prime number is 3, since there is nothing that 2 can divide here. So we're going to use the prime number, which is 3. 5 divided 3 is still 5, because 5 cannot divide 3 without remainder. Then the next one, 3 divided 3 is 1. So since there is no number that 3 can divide here, we'll use 5. Since 5 is the next prime number, 5 divided 5 is 1. Here is 1. So we have 2 by 3 by 5. 2 times 3 is 6, and 6 times 5 is 30. So this is the LCM. We'll come back here and write 30. So 30 divided 3 is what? Is actually 10. So it's 10. And 10 times 2. Remember, never you write, don't think is, don't you say 30 divide 3 is 10 and you write 10 here. No, you have to multiply it by the numerator. So 30 divide 3 is 10, and 10 divide 2 is now 20, minus 30 divide 10 is 3, right? It's going to be 3. And 3 times 5 is 15. So we're going to write 15 here. So 20 minus 15 is actually 5 divide 30. And what can go into between 5 and 30 is 5. 5 here is 1 and 5 here is 6. So the answer is 1 over 6. So this is the answer. Alright. Sometimes you may also have fractions that have different denominators that are in form of mixed fraction. How are we going to do? For example, we have 6 whole number 1 over 3 minus 3 whole number 1 over 2. How are we going to handle this? The first thing to do is you may use the method of conversion to improper fraction, which is 6 by 3 is 18. 18 plus 1 is 19. So 19 divide 3 minus 3 times 2 is 6, and 6 plus 1 is 7. So it's going to be 7 divide 2. Since the denominators are different, we're going to find the LCM. In finding the LCM, we have 3 and 2. So what can go? We have 2 here. 3 divide 2 cannot go. Write the 3. 2 divide 2 is 1. And the next one is 3, which is 1, 1. So 2 times 3 is 6. So the LCM here is going to be 6. So 6 divided by 3 is 3. And 3 times 19 is going to be 38. And see, minus 6 here divide 2 is what? 3. And 3 times 7 is 21. So we have 38 minus 21 is going to be 17, right? So we have 17 divide 6. And 17 divided by 6, 17 divide 6 is going to be 2 remainder 5. So 2 remainder 5 over 6. So that's the answer. Alright, sometimes you may encounter numbers subtracting or adding a fraction with a whole number. For example, we have 8 whole number 2 over 3 minus 4. 4 is a whole number, while this one is a mixed. This is a mixed number and this is a whole number. How are you going to go about it? This is a simple way. The simple way to go about it is just balance this one with 1. Balancing this one with 1, change this entire one to improper fraction. So 8 times 3 is 24, and 24 plus 2 is 26, right? So we have 26 over 3, then we have minus now 4 over 1. So find the LCM. The LCM here, if you find the LCM, since it's 3 and 1, the LCM will be 3, right? So 3 divided 3 is 1. 1 times 26 is going to give us 26. So we have 26 minus 3 divided by 1 is same thing as 3. And 3 times 4 is 12, right? So we're going to have 12. So 26 minus 12 is 14. So we're going to have 14 divided 3. And this is an improper fraction. If you divide it, it's going to have 4 remainder 2, right? So it will be 4 whole number 2 over 3. So whenever the number is a whole number, just balance it with 1, just the way we did here, right? So I hope with this you are totally comfortable to confront any question that has to do with addition and subtraction of fraction. Alright, before I end of the lesson. I have 4 questions as an assignment for you here. Try and solve it and look for more problems. Practice and make sure you're comfortable with it. Remember that practice makes perfect. Thank you for watching. See you in the next lesson.